We are now describing lab 3. This is the lab about the formation of the image of a convex lens and describing the image and also finding the focal length of the lens. This lab is done in two parts. One part is as it is shown in the book by finding out the approximate focal length using two diode lasers. The other one is a regular measurement of focal length using an optical bench. So this shows you schematically what we are going to do. Here is the double convex lens, and we have an object here at a certain distance. It has to be somewhere at least beyond the focal length, because we know that less than focal length there will not be any real image, there will be only a virtual image. Therefore, your object has to be not less than focal length and not even on the focus. It has to be beyond the focus. It can be between f and 2f, or it can be beyond 2f. So when you do this one, and if you ray trace it, that is, you take a parallel beam and then take it to the focal point, then you get one ray, and the blue ray which goes directly to the lens. These two will intersect at the point where you have the image. One can easily see in this picture that in this case, when the object is beyond 2f, the image will be formed between f and 2f, and it's an inverted and it's a real image. So when we perform the experiment with the optical bench, which I'll be showing in a little while, you can move the object distance anywhere between f and 2f, 2f and beyond 2f, and then catch the image. We can calculate the focal length also. That also will go in a minute, and that is the way in which we will use this. This is the one that is given in the book on page 167. This is how you can find out the approximate focal length. You use two diode lasers, and these two are put in a stand, and here's the lens, and you can focus these two onto a screen at a point which is beyond the focal length. These two spots appear as two individual spots. When you move the screen to an exact point where these two coincide into a single spot, this will be shown in the experiment itself, then the distance between these two is the focal length. Alternatively, you can also measure the focal length by focusing a distant object to a window onto a wall, and the distance between the image on the wall and the lens itself is the approximate focal length. You can choose either one of them to do the approximate focal length. Once you have known that, then we will go to the optical bench. Here is the lamp which will serve as our object. In front of the lamp, we have a cross, that is your actual object, and then we have a lens holder in which we can hold the lens, and we can have the screen, and all these things are mounted on the optical bench. So to start the experiment, you put the lens at a distance between f and 2f from the object, and you measure the object distance, that is p, and then catch the image, make the image sharp, and you measure the image distance, that is q. So if you go here, 1 over f equals to 1 over p plus 1 over q, or f equals to pq over p plus q. So you can use different p's and their corresponding q's and to find out the focal length, remembering that there's only one focal length for a given lens. So this is shown in a table here. In this one, you can use several lenses, not necessarily one lens. Then you find out the p, the q, and then from there you can find out the f and compare that with the approximate focal length. And you can find out the percentage error also. This is how you can measure the focal length of a lens as well as describe the image of a positive lens.